Combined circuits, a series parallel circuit. Okay, I'm going to teach you a series parallel circuit. This exact problem is number 25 on page 638. Okay, here you have a parallel resistors and they're in series with one. What do you do? What do you do? Well, if you do your reading, you will remember, you will know that you combine the parallels first so that they make one big series circuit, and then you add them together. Okay? So we're going to do this problem, a series circuit similar to the one in example problem 4, this one, has 3 resistors. One uses 2 watts. So this one right here says it is 2.0 watts, which is power, not resistance. The second is 3.0 watts, which is power, not resistance. And the third is 1.5 watts, which is power, not resistance, and it's attached to a 12-volt battery. So, let's figure this out. We know power equals current times volts. You guys also know that volts equals current times resistance. Well, guess what? We don't have current. Okay? We don't. But we do have volts, and we have, we are looking for resistance. We don't have current, though. So how about we do this? How about we take V over R equals I, and we plug this guy right where that I is. And then we'll have power equals V squared over R. Okay, now we can find out what the resistance are in ohms. Because we have power in watts, and we have volts. So let's find out the R using that equation at each one of these resistors. All right, here we go. Let's get rid of that so we can write. Right here we have 2 watts, and we have 12 volts. Okay, so for resistor 1, power equals V squared over R. 12 volts equals 2.0. I'm sorry, I messed that up already. Switched them. Okay, so sorry. Our power is 2 watts. Okay, our volts is 12 squared. We're solving for R1. Okay, and at 2 watts, our R1 is 72 ohms. All right, next, let's find for R2. R2, okay, we have 3 watts of power, we have 12 volts. Power equals V squared over R. R equals V squared over power. So that is 12 squared over 3 watts. Now our R is 48 ohms. And then for our third one, same deal for R number 3. Okay, R is equal to V squared over power, and R is 12 squared divided by 1.5 watts. And that would be 96 ohms. Okay, now we are ready to solve the rest of it. Now we're ready. Okay, and we're fine. Let's see, how much current does the circuit require from a 12 volt? First thing we're going to do is we're going to add 72 ohms and 48 ohms in parallel. How do we do that? That's right, we reciprocate. Reciprocal. Okay, 1 over 72 plus 1 over 48. Okay, so what is the common denominator between 72 and 48? Let's see, 1 over 72, 1 divided by 72. I'm going to pause the video. Hold on. All right, so now that I got a fraction straight, 1 over, let's see, 2 over 144 plus 3 over 144, and that's 5 over 144. Well, then what is our total for this? Well, our total for this is 144 divided by 5. So that's approximately 29 ohms. Okay? So these two together, we'll get rid of this and we'll count it as one big ohms. Okay, well, that's 29 ohms now. Now, we're in series with 96 ohms. So how do we add them in series? Well, that's way easier to do. So here we go. Adding them in series. That would be 96 ohms plus 29. 96 ohms plus 29 is 125 ohms. There is my total for the entire circuit. So now at the very end, I go V total equals I times R total. What is my current now that it's a series and parallel circuit? Well, use 12 volts again, divide it by 125 ohms, and that will give us a current of 0.096 amps. Okay, so first combine the parallels, solve the resistance, then add the series, solve the resistance, and then V equals IR. That's it. Now do the rest of the problems in the book.